The concept of artificial intelligence is not new. It has roots in ancient myths and stories. The Greeks imagined automatons, mechanical beings with human-like abilities. These myths reflected a fascination with the possibility of creating artificial life. The desire to imbue inanimate objects with intelligence has captivated humanity for centuries. In Jewish folklore, the golem was an animated anthropomorphic being. It was created entirely from inanimate matter, often clay or mud. The golem was brought to life by mystical means, typically by inscribing Hebrew letters on its forehead or placing a scroll in its mouth. It served as a protector of the Jewish people, carrying out tasks that required immense strength or unwavering loyalty. These early imaginings, while fantastical, laid the groundwork for the pursuit of artificial intelligence. They demonstrated a fundamental human desire to understand and replicate the complexities of the mind. The true foundation for artificial intelligence was laid with the development of the modern computer in the mid-20th century. The ability to process information at incredible speeds and perform complex calculations created unprecedented possibilities. Pioneers like Alan Turing envisioned machines capable of mimicking human thought processes. The invention of the transistor in 1947 revolutionized computing. Transistors, tiny electronic switches, replaced bulky vacuum tubes. This led to the development of smaller, faster, and more affordable computers. These advancements paved the way for the emergence of artificial intelligence as a distinct field of study. The development of the first high-level programming languages, such as Fortran and COBOL, further accelerated progress. These languages allowed programmers to write instructions in a more human-readable form, making it easier to create complex software. The stage was set for a revolution in artificial intelligence. In 1950, Alan Turing proposed a groundbreaking test for artificial intelligence. Known as the Turing test, it aimed to determine a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. The test involved a human evaluator engaging in natural language conversations with both a human and a machine, without knowing which was which. If the evaluator could not reliably distinguish the machine from the human based on their responses, the machine would be considered to have passed the test. The Turing test became a cornerstone of AI research, sparking debate and inspiring generations of scientists to push the boundaries of what machines could achieve. The Turing test, while controversial, highlighted the importance of natural language processing and communication in the quest for artificial intelligence. It set a high bar for AI development, challenging researchers to create machines capable of understanding and responding to human language in a meaningful way. The term artificial intelligence was coined at the Dartmouth Conference in 1956. This pivotal event brought together leading mathematicians, computer scientists, and cognitive researchers. It marked the official birth of AI as a distinct field of study. The conference explored a wide range of topics related to artificial intelligence, including problem-solving, learning, and natural language processing. It fostered collaboration and sparked a wave of new research initiatives. The Dartmouth Conference laid the foundation for the rapid advancements in AI that would follow. The researchers at Dartmouth shared an optimistic vision of the future. They believed that significant breakthroughs in AI were within reach. While some of their predictions proved overly optimistic in the short term, the conference ignited a spark that would continue to drive AI research for decades to come. Section 5: Symbolic AI, the Rise of Logic and Language. Early AI research focused heavily on symbolic AI, a paradigm based on the manipulation of symbols and rules. Researchers believed that intelligence could be replicated by creating systems that could process information logically and follow predefined instructions. Symbolic AI led to the development of expert systems. These systems were designed to mimic the decision-making abilities of human experts in specific domains. Expert systems proved successful in limited applications, such as medical diagnosis and financial analysis. However, symbolic AI faced limitations in handling the complexities of the real world. It struggled with tasks that required common-sense reasoning, intuition, and the ability to learn from experience. The limitations of symbolic AI became increasingly apparent as researchers tackled more ambitious challenges. Section 6: Early AI Programs, Planting the Seeds of Progress. The early days of AI saw the emergence of groundbreaking programs that demonstrated the potential of this nascent field. These programs, while rudimentary by today's standards, showcased the ability of machines to solve problems, play games, and even generate creative text formats. One notable example was the logic theorist, developed by Alan Newell and Herbert A. Simon in 1955. This program was designed to prove mathematical theorems using the principles of symbolic logic. It successfully proved 38 of the first 52 theorems in Principia Mathematica, a seminal work in mathematical logic. Another influential program was ELIZA, created by Joseph Weizenbaum in 1966. ELIZA was an early natural language processing program that mimicked the conversational style of a Rogerian psychotherapist. Despite its simplicity, ELIZA demonstrated the potential of computers to engage in human-like conversations, albeit in a limited way. Section 7. Overcoming Obstacles: The Challenges of Early AI. Despite the initial enthusiasm and promising early results, AI research faced significant challenges in the 1960s and 1970s. Researchers encountered fundamental limitations in computing power, data availability, and algorithmic sophistication. Natural language processing proved to be a particularly difficult nut to crack. Understanding the nuances of human language with its ambiguities, idioms, and context-dependent meanings posed a formidable challenge for AI systems. Early attempts at machine translation often produced humorous or nonsensical results. Moreover, AI systems struggled to generalize their knowledge and adapt to new situations. They excelled at performing well-defined tasks within their narrow domains of expertise, but faltered when faced with unfamiliar scenarios. This lack of flexibility and common-sense reasoning hindered progress in developing truly intelligent machines. Section 8. The AI Winter, a Period of Dormancy. The ambitious promises of early AI researchers were met with limited success, leading to a period of disillusionment and reduced funding in the 1970s and 1980s. This period, known as the AI Winter, saw a decline in both academic research and commercial investment in artificial intelligence. The AI Winter was partly driven by unmet expectations. The initial hype surrounding AI had raised hopes for rapid progress towards human-level intelligence. When these expectations failed to materialize, disappointment set in. Funding agencies became skeptical of AI's potential, leading to a decline in research grants. Furthermore, AI research faced competition from other emerging fields, such as personal computing and software engineering. These fields offered more immediate practical applications and attracted significant investment, overshadowing AI's long-term potential. Section 9. The resurgence of AI machine learning takes center stage. The late 1980s and 1990s witnessed a resurgence of AI, fueled by the emergence of machine learning. Unlike symbolic AI, which relied on explicit rules and symbols, machine learning allowed computers to learn from data without being explicitly programmed. Machine learning algorithms, inspired by the structure and function of the human brain, enabled computers to recognize patterns, make predictions, and improve their performance over time. This data-driven approach proved particularly effective in areas such as image recognition, speech processing, and natural language understanding. The availability of large datasets and the exponential growth in computing power further accelerated progress in machine learning. Researchers could now train sophisticated models on massive amounts of data, leading to significant improvements in accuracy and performance. Section 10. Modern AI, a new era of breakthroughs. The 21st century has witnessed an explosion of AI breakthroughs, driven by big data, cloud computing, and advanced algorithms. AI is transforming industries, automating tasks, and integrating into our daily lives. IBM's Watson supercomputer's victory in Jeopardy! In 2011 was a notable AI milestone. In 2016, Google's AlphaGo defeated a world champion Go player, showcasing deep learning's power. Section 11. AI in the 21st century, shaping the future. As AI advances, it reshapes our world. From self-driving cars and personalized medicine to smart homes and intelligent assistants, AI is transforming industries and enhancing daily life. However, rapid AI progress raises ethical considerations. As machines become more intelligent and autonomous, questions arise about job displacement and algorithmic bias. The potential misuse of AI for malicious purposes is a concern. Developing ethical guidelines and regulations is crucial. The future of AI holds promise and uncertainty. As we unlock intelligence and create advanced machines, it is essential to proceed with caution and wisdom. The choices we make today will shape AI's impact on humanity.